Hello, my name is Uriel and I'd like to talk to you about the program LivePyxel. LivePyxel is an application that is based on a graphic user interface. Its objective is to allow the user to make quick annotations that can then be integrated with certain architectures of machine learning applications, in particular Unit, which allows the user to create implementations for instance segmentation. In this tutorial, we'll see how to install it from scratch, assuming that we already have a Python installation in place. I'm going to be using Anaconda for this. So let's get started. I'm going to click in the green button code and I'm going to copy the HTTPS. Then I'm going to go to the desktop and I am going to clone the repository. To clone the repository, I can start a new terminal in the current directory. I'm going to press Ctrl L to highlight the path, and I am gonna replace it with the words CMD. Once I'm here, I'm gonna click Git clone, and I am gonna right click. Then I press enter. The program is pretty light, and the way it works is as a Python application that is in charge of the backend, and the front end is being controlled by a special library called PyQt5. PyQt5 is not exclusive to Python. Well, PyQt5 is, but Qt5 is a special tool that allows users to generate graphic user interfaces and is widely used in other types of related programs like Napari. Once we have cloned the repository, we can enter that repository and we will see a requirements.yaml document. This document is going to have to be read in order to install the Anaconda environment that we need to run the application. To run it, in the terminal, I am going to enter first the name of the repository, which is LivePyxel. Once I'm inside, I can double check that I have all of the elements that make part of the repository, and I see in there that the requirements is selected. If you go to the GitHub repository, the installation instructions also include this line right here. I'm going to copy it and I'm going to paste it. The objective here is to create a new environment. Oops. Copy. There it is, copied. And then I'm going to right click to create a new environment. While this is happening, which will probably take a couple of minutes because it has to install CV2 or OpenCV, and OpenCV is a very powerful interface that allows for object detection and image manipulation using a special type of representation of matrices called a NumPy array. So while this is happening, let me show you what the requirements document contains. To access the requirements.yaml file, I'm going to open my coding editor. In my case, I can open a new terminal and type code. Then it's gonna prompt a new folder opened via VS Code in the location where that folder is. And here I can see that the requirements YAML represents the instructions to create a new environment that is gonna be called LivePyxel-emp. LivePyxel-emp is gonna contain the library PyQt5 that is installed via pip, but it is also gonna include OpenCV. Now, I'm not sure how to install OpenCV using something other than Anaconda environment. I have done it in the past, but I remember that the wheels that were built were a little hard to debug when something goes wrong. Nowadays, the installations and the versions of CV2 available are more thoroughly tested, but I still recommend using Anaconda or an environment manager for this purpose. After a couple of minutes, maybe 8 or 10 minutes, we can see that CV2 has already been installed and the environment has successfully been inserted into our Anaconda environments. So here we can activate the environment as it is read here by copying the conda activate LivePyxel-emp, and I can right click here in the terminal, making sure that I am still in the folder where I can find the rest of the Python files in order to open the application. Once we are inside of the environment, LivePyxel is going to appear on the left and I know I'm ready to go. Inside of the repository, you will notice that there is multiple Python files. Most of these files are helpers, submodules that are summoned by the main program, which is called main.py. So here we can run it using the Python call to the python.x that has been installed in this environment, followed by main.py. I press enter, and if everything works well and our environment was successfully set via the requirements file, we should see an ASCII art representation of a webcam pointing at the process of trying to find the different webcams that are associated with our device. By default, the camera that is selected is often the webcam that you normally use for Zoom conferences and the sort. The intention of this program is for you to have access to hardware that allows you to also read the microscope or application that you have intended in such a way that can be read directly by Python. Once we have the application, we can talk about the different elements. At the top left corner, we can start new projects by clicking in the file element in the menu bar. The new option is going to allow us to select a specific folder that is going to contain a set of subfolders to save the annotations for our program. I'm going to click in here and I'm going to create a new folder inside of the repository for now. It doesn't have to be that way. You can put the folder wherever you want, but I'm just going to call it test for now. I click enter to confirm my selection, and then I can select the folder by clicking in the button, by clicking in that button. So the project has now been saved, and now I'm ready to create my annotations. The window is divided into 4 different subsections. We're going to start with this one at the top right corner. It has 3 buttons. The first one, which is called Annotate, will allow us to save the annotations or colors that we have added to the image that we have as a reference into the masks folder inside of the project that we just created. The second one, which is the Switch Webcam, which is the one I'm about to click right now, will allow us to change the webcam so that I can start using the one that is actually attached to my microscope. Depending on how many webcams you have, and as long as your operative system recognizes them as webcams, you should be able to enter each of those different webcams by clicking this button. The process is cyclic, so once it finishes iterating over all of the possible webcams, it goes back to the beginning, which is the original default webcam. So once I am here, I can find a specimen that I may find interesting, not spending too much time on it. The sample that you are looking at right now, in case you are curious, is from a sample of a pond here in Toronto that I've been keeping for over 3 months now. And you can see that is quite healthy in terms of its population of nematodes. So this is a good sample, I think, and I just need to find a specimen that I feel happy with annotating in order to begin the demonstration. And this takes us to the third element, the capture button, which I had to click just now. So this button will allow us to freeze the image in order to begin the annotations. The second submenu that we can talk about is going to be the different icon buttons. LivePyxel contains 3 different modes. The first one is polygons. Polygons will allow me to use a special cursor to outline the perimeter of an object. And it works great when you have things that are really straight. The program works by just adding clicks, and if I need to reset the annotation or if I change my mind on the sequence of vertices, I can press Ctrl Z in order to undo it. At this point, the program doesn't have the redo button, so the program simply erases the previous one, so you need to keep that in mind so you can continue until you are happy with the annotation. Once I'm happy with the outline that I created, I can press the Enter button. Once I press Enter, the annotation is confirmed, and then I can make it permanent in the mask. On the left panel, we have the different labels for our annotations. If I click in this button right here, a new dialog box shows up, and it will allow me to change the color of this label and also the name of that label. So these are nematodes. So I'm going to call it as such, and I'm going to keep the color the same for now. I'm going to press OK. And you can see that the label name has changed to nematode. Let's edit the other label. And I don't know what else I'm going to find, so I'm going to call it SP1 for whatever that is. And I can click in the color picker. I'm gonna change the color to, let's say, something really vibrant. In your project, you may have the need of selecting a particular color composition because they reflect something for your categorization. So I added that feature to the program. I'm gonna click OK, and you can see that the label changes and also the elements that make part of the mask. So I can press enter now, and the polygon for the label SP1 has now been confirmed. So here I can go back to edit, and instead of green, let's suppose that I want something that looks more like purple. I click OK, and you should notice that the color of the mask has changed next to the label, but it has also been applied to the annotation that you have. Because even though you change the color of a particular annotation, those that you had already saved have not been modified. Let's go to the next tool. So let's suppose that I want instead to color things my way. I click in the brush tool, and here I can control with the scroll of the mouse the diameter of the brush that I'm gonna be using. Here is another nematode, so I'm gonna start my annotation here. I can use the brush tool in erasing mode. By right-clicking with the mouse, I can simply pass the brush on top of the previous annotations, and that is how I can remove them. The third tool is particularly powerful, and it involves the use of Bezier curves. Sometimes you have certain objects that can be represented as circumferences, and using the polygons makes a good approximation, but is not perfect. So the Bezier curve allows me to instead click once to create a straight line that I can drag anywhere inside of my image. And once I find the tip of the curved object that I want to outline, I can press with the left button of the mouse once more without releasing the button. Then I can simply drag inwards or outwards in order to turn that line into a curve. There is a point that is facing away of the cursor, and that one represents the anchoring point. You can think about it as a point of gravity that is pulling the otherwise straight line into a curve. The farther I leave it, the more curved my Bezier is gonna be. The purpose is to accumulate multiple of these curves to create what is known as a spline. A Bezier spline is one of the most important tools in image processing and image editors like Photoshop and Illustrator, and I considered that it was important to use it here. For my purposes, in terms of microscopy, I have already noticed that it helps a lot with the specimens of things like ostracods that are basically round organisms. Once I'm happy with it, I can press enter and I can confirm the selection. So if I am in the brush tool or any other tool for that matter, and I want to see a little bit more of the specimen and the color of my mask is in the way, because I maybe ate too much of the outline, I can modify the mask opacity. The mask opacity will allow me to make the annotations that I already have into a more transparent or more opaque view of the same annotation. So in this case, I'm gonna lower the mask opacity and I can start erasing the elements that are not supposed to be part of the contour. Once I'm happy with the annotation, I can return the mask opacity. So once I'm happy with the annotation, I can finally save it by clicking on the annotate button. You will notice that the annotations disappear, and this reflects that the program successfully saved the image inside of the subfolders. If you want to save the labels at any time, you can press Ctrl S. The program will pop a confirmation letting you know that the information on the labels has been saved. However, the annotation is not saved. So before you close the program, please make sure that you have finished your latest annotation. So here we can also load a folder. To load a folder, you need to go to the folder that contains your project, which in my case is called test, and you will notice that there is in there a file called config.json. A JSON is a special format that contains details on the name of the labels and other parameters important for the program. So here I can click on the config.json and I can select open. If the program works properly, you will notice that the colors have been restored to what they had been saved at the time when the program was last saved. In the menu bar, you can also find the tutorial section, which is going to prompt you to the official documentation of LivePyxel, which is hosted on GitHub Pages, where you're also going to find the links for this tutorial. If for whatever reason you need to make contact as well, you can select the contact information and then you can visit the website where you will find information on how to reach out to me. And that is it. Before we call it a day, let's make sure to capture another sample, something over here. Let's say something over here like that. And let's add a new tag. I can click in the green button here at the bottom and that will create a new label. This new label is gonna represent a proto-swan. So I'm just gonna call it proto_sp1. You can leave spaces, but I don't recommend leaving spaces. Here, I'm gonna change the color to green and I'm gonna click OK. With that, I can go to my Bezier curves and I can use the splines to delimit the boundaries of this specimen. Once I'm happy with my selection, I press enter once more and I can click annotate. Let's suppose that I forget to save the program before closing it. I go to the top right corner and I click X. The program will ask you if you want to save the project. From here, you can decide what you want to do. And in my case, I'm going to select yes. It saves the project and then it closes the program. Inside of the project of my folder, I'm going to find two subfolders. The first one, images, contains a catalog or collection with the photographs that I took for each annotation. Notice that the name always starts with img, and the second element is a special type of code that is generated, not entirely at random. It uses a special sublibrary called UUID. That is very useful and almost guarantees that no two images are going to be named the same, right? So we have 8 different digits, so the probability of getting that is pretty low. However, if you encounter situations in which you need to go beyond the 8 million element datasets, then you can easily modify it. And I can include that in further tutorials. If you need that, please reach out and I'll be happy to help. The second one is going to be the masks. The mask contains the exact same information, the exact same unique identifier, but this time is called the mask. Once you have this, you can build your dataset that is going to receive the images folder and the masks folder in order to train your model using UNet or other architectures for image segmentation, with the goal of training the program to make this process automatic. Future versions of this program are also going to include an option for you to load the model directly once you have trained it, so that you can initiate the prediction very quickly. There has been an increment in the number of applications of this type, particularly with the release of SAM, which is the Segment Anything model that was provided by the FAIR group, the Facebook AI research group. And in future implementations, I hope to also integrate it. However, I need to make sure that I keep the program light. What is unique about LivePyxel is the flexibility of using the webcam in order to make the process faster and more user-friendly.